share my screen with you. Like I said, it's still the same topic, coordinate geometry of a straight line. So we want to round it up. So I have my slide here. Okay. So let's just have a look at sorry. Okay. Yeah. So this is the beginning of it. We have done this one last week. So we looked at the area of gradient, we looked at the area of equation of a line, and at that, I think that's where we stopped. We were able to look at gradient intercept form, gradient and 1 point form, 2 point form, and general equation. I want to believe that there's no problem on all these ones. So for today, we want to look at intersection of lines. When two lines intersect, what does it? What do we see there? What happened? Then we also want to look at angles between two lines. So what happened in the angle between two lines? If you use tangent, then if you want to narrow it down to what happened to parallel lines and perpendicular lines. So that's what we want to look at. So these are some of the things that we did last week. I want to believe that there's no problem. So and I think this is where we stopped last time, where we concluded on the general equation. That is another equation that we can also apply. We said this is the general equation actually. This is the general equation. So we can also have, if we are given two intercepts, the intercept on y and the intercept on x. The intercept on this is the intercept on x, this is x. So where the line cuts the x is what we call the intercept on x, and it is at point A. So it means that A will be below x. You can see that will be the denominator of x. Then the intercept on y, where it cuts y, that's B. That B will be the what? The denominator of y. So you equate it to 1. As simple as that. So this is the general equation. This is another way we can also find the equation of a line. So that one is just very, very straightforward. Sometimes they may give you a line of this nature. They give you, this is point, maybe this is 0.2, this is 0.3. And they want you to find the equation of that line. You can see that it's very simple to do. What you just do is what? The A intercept on x is 2. So that would be x over 2 plus what? Intercept on y is 3. Y over 3 equals to 1. So don't make noise. So the element, the denominator, the SCM of that denominator is 6. Just multiply it through by 6. You have what? You have 3x plus 2y equals to 6. So 3x plus 2y equals to 6. That's the equation of such a straight line. So as simple as that. So we want to today, and that is intersection of lines. So when two lines intersect, so what happened? When two lines intersect, we realize that what? The point of intersection, we can get it by solving the what? The equation simultaneously. Look at this question now. So by solving the equation, following a simultaneous equation, find the coordinates of the point of intersection of the lines 2x plus 3. Yeah, that's a mistake. It's 2x plus 3y. It's 2x plus 3y. 2x plus 3y equals what? Equals 16. So please, you can correct it there. I will correct it before I send this thing out. So you can correct it in your own place there. So it is what? 2x plus 3y. 2x plus 3y. Oh, sorry. It is 2y plus 3x. 2y plus 3x. It's 2y plus 3x. So it's 2y plus 3x. 2y plus 3x equals to 16. And this is the second one. So 7y equals to 2x plus 6. So in such a case, what do we do? So we want to solve that equation. We want to solve that. We say we should solve it simultaneously. So then they say, hence, find the equation of the line through this point with gradient minus 2. With gradient of minus 2. So what you just need to do is what? Can we solve the two equations simultaneously? Yeah. So that's what we just need to do. So I have 2y plus 3x equals to 16. So if I need to solve it with 7y, if I rewrite that one, so I have 7y minus 2x equals to 6. So I so much love elimination. So if you have to apply elimination, multiply the above by 2, the equation 1 by 2, equation 2 by 3. So we have 4y plus 6x equals to what? Equals to 32. The second one, multiply it by 3. We have what? 21y plus, sorry, minus. So minus, stop me. Minus 6x equals to, multiply this one 2 by 3, that's 18. So in this case, since they have different signs, so you have to add them together. So you have 25y equals to 50. So y is 2. So if y is 2, what happened? We need to get the value of x. So if you put x, if you put y there, so if you put it in the first equation, for example, 2 times 2, I have 4 plus 3x equals to 16. So 16 minus 4 will give me what? 12. So 3x is equals to 12. And that x is equals to 4. So it means the point of intersection is what? 4, 2. So they said, hence, find the equation of the line through this point with gradient minus 2. So what does that mean? It means we have a point now. And the gradient has been given as what? Minus 2. So it means gradient and a point form. And what formula do we apply? Y minus y1 over x minus x1 is equals to the gradient. So if you apply that, that would be y minus 2 over x minus 4 equals to what? Equals to minus 2. So if you cross multiply, y minus 2 equals to minus 2x plus 8. So if you have to, you can just make sure that we collect like terms. That minus 2 should, minus 2 and plus 8. How do you bring them together to join them together? So in this case, I can just simply put it as y equals to y. I can even bring minus 2x inside. So y plus 2x. If I bring minus 8 to plus 8 inside, it will give me minus 10 equals to 0. So you can leave it like this. If you like, you can leave it as y equals to 2x equals to y plus 2x equals to 10. If you like, you can also put it as y equals to what? Minus 2x plus 10. So that is how we can then solve that question. Say by solving the following simultaneous equation, find the coordinate of the point of intersection of that. So I've said that this is what? It is what? It is 2y plus 3x, not 2x plus 3x. So that is that. So it means we solve the two equations simultaneously first. Having solved that, the answer you get, x and y, will be a coordinate, a point. So, and that is point of what? 4, 2. Then they say we should find the gradient of a line that passed through such points, and then whose gradient is minus 2. They want us to find the equation of such a line. And that is what you have done now, using what? 1 point and gradient form. So y minus y1 by x minus x1 equals to m. So as simple as that. So I hope there's no problem. If there's no problem, let me move to the next question. For the next question, okay, I think it's still on this. Yeah, it's still on this. We just want to solve maybe one more question. Say find the coordinate of the vertices of the triangle formed by the lines. We have three lines, three lines form a triangle. L1 is 2x plus 3y equals 5. L2 is what? 3x minus y equals to 2. And L3 is what? 4y minus x equals to 14. It says find the coordinate of the vertices. I want to believe you know what you mean by vertices. So when you have a triangle, the point where two lines join. Yeah, so these are the vertices. So they want us to find the vertices. They have given us equation of the lines. You can see that the lines intersect. So where they intersect, you have to solve the simultaneous equation and get the point. Then they said, hence, find the equation of the line through the point of intersection of L1 and L3 and parallel to what? L2. So parallel to L2. So maybe we may delay that question because of what they mentioned here, parallel. When we say something is parallel, but before we may not delay it. We are not delaying all the question in totality. I'm just saying that we can delay the last part of it. They say, hence, find the equation of the line through the point of intersection of L1. We may just say this is L1, this is L2, and this is what? L3. So maybe we may have to come back to the question. But what the first one, find the coordinate. This is L1, L2. Solve the two equations together. 2x plus 3y equals to 5. And then 3x minus y equals to 2. Solve these two equations together. When you solve, the x and y that you get, that's it. This will be where you are going to put it. So for the second one, L2, L3, if you solve L2, L3 together, 3x minus y equals to 2. 4y minus, I will just want to rearrange it so that it suits what I have here. So if I need to rearrange that, I will not write 4y first. So I may just write minus x first, minus x plus 4y equals to 14. So that's the second. So that one will give us this point. Then to get the last one, you can solve L3 and L1. L3, L1. What do we have in L3? L3, I have what? 4y minus x equals to 14. L1, I have 2x. So if I need to solve that, if I write L1 first, it doesn't matter. If I'm writing L1 first, 2x plus 3y equals to 5. And L3, I may need to rearrange it like I did the other time. X minus x plus 4y equals to 14. So if I have to do that, 4, okay. So if I have to do that, so yeah, how do I solve? So you solve them simultaneously. The time may not permit us to solve, but I want to believe that you understand what we are trying to drive at here. So this is further math class. So whatever you solve, so in the next, maybe before we finish the class today, we can come back to it. So just like we did the other one, you can multiply this one by what? Multiply this one by 3, multiply this one by 2. So this is what? 6x plus 9y equals to 15. The second one, that will be 6x minus 2y equals to 4. So if I subtract 7 minus 9 minus 2, will give me what? Will give me 11. Yeah, plus 11y. 15 minus 4 will also give me 11. So it means that what? Y is equals to, so it means y is equals to what? 1. So if y is 1, what is my x? You can just put it there directly. There's no space and whatsoever here. So if you put y equals to 1 here, so it means 3 times 1 will give me 3 times 1 here will give me what? Will give me 3. Take it to the other side there. 5 minus 3 will give me 2. So 2x is equals to what? 2. And x is also equals to 1. So it means x will also be equals to 1. So as a result, this place will be 1, 1. So that is 1, 1. So I will go to the second one too. Since this one is, I may not need to multiply equation 1 by anything or by 1. Equation 2 by what? By 3. So I'm going to have what? 3x minus y equals to 2. Then I have what? Minus 3x plus 12y equals to what? 14 times 3. 14 times 3 will give me what? That's 52, I mean. 2 times 4, 12. Yeah, that's 42. 42. So, since they have different sign, I need to add them together. So, minus y minus 12. That will give me what? I hope I'm right there, yeah. So, minus y minus plus 12. And that will give me what? Minus 13y. Minus 13y. Am I right? Sorry, I'm adding, sorry. I'm adding. Okay, thank you. So I'm adding minus y plus, minus y plus what? 12y. And that will give me what? 11y. So that will give me 11y equals to 2 plus this will give me 44. So if I add, so it means y is equals to 4. So if y is equal to 4, what is x? So if I put, for example, if I put in equation 1, if I put 4 there, that will be 3x minus 4. Minus 4 will go there, it becomes plus 4. So 2 plus 4 will give me 6. X will be equals to what? The Bible says by 3, x will be equals to 2. So x is 2. So it means that will be 2, 4. This place is what? 2, 4. So you find the last one. So which do I need to find out for us? Let's go. Okay, let's find it so that by the time we want to come back to solve this, if time still permit us. Yeah, if time still permit us. Okay, so to solve this, you can do the same thing like we have done in the second one. So I don't need to multiply since I have minus 1 minus x here. I don't need to multiply equation 1, or I multiply it by just 1. Equation 2, I multiply it by 2. So I have 2x plus 3y equals to 5. So the second one multiplied by 2, I have minus 2x. So minus 2x, multiply this one by, so that would be plus 8 equals to what? 28. So here too, because I have different signs, plus 2 and minus 2, I'm going to add. So 3 plus 8 will give me what? 11. 11y. And then 5 plus 28 will give me 33. So y equals to 3. So if y is 3, what is x? So I may use equation 2 here. So 3 times 4 is 12. 12 will go to the other side. 14 minus 12 will give me what? 2. So minus s equals to 2. It means s is equals to minus 2. So x is minus 2. So it means this place, s is minus 2. And y is what? Y is 3. So we have been able to solve the first part of that particular question. So maybe before we end it, or I'll give you this, in fact, let me give you as an assignment. Before the end of this class, we'll be able to know how we can solve such a question. So since I haven't got this now, we have got the point of intersection. So hence, find the equation of the line through the point of intersection of L1 and L3. L1, L3, this is the point. So this is the point they are talking about. So it means they have given us 1 point. It's passing through this particular point. They have given us 1 point. So another thing that they also need to give us is either they give us additional points or they give us gradient. But they have not said parallel to what? L2. Parallel to L2. So before the end of this class, you know how you can do that. So it means we need to pick our gradient from the gradient of what? L2. So how do we pick our gradient? The gradient that I'm going to use, you have to pick it from what? Line 2. So I will tell us how we can do that. Okay. I hope there's no problem. We can leave this page. So if there's no question, let's move on. Okay. So angles between two lines. So when I think it's also part of what we have just, yeah, is part. Okay, angles. We have to look at angle. We have just treated intersection. So angle between two lines. Now, when we want to find angles between two lines, in further maths, in this particular aspect of mathematics, anytime we mention angles between two lines, we always think of two things, two ways. The first way is that in vectors, we have been taught dot product, A dot B. A dot B equals to, that is dot multiplication equals to what? Magnitude of A multiplied by magnitude of B cos theta. So you can make theta the cos theta set of formula here. If you make cos theta set of formula, it means that what? We are going to have cos theta is equals to what? A dot B over magnitude of A, magnitude of B. So now if you want to find your theta, at the end of the day, you start equals to what? Arc cos A dot B over magnitude of B. Sometimes this expression may give us what? It may give us a negative answer. So we are going to consider it based on what you have been taught in what trigonometry before. So if they say we are looking for the acute angle, look at this question now. We are looking for the acute angle. It means that when you even get negative, that negativity, you have to turn it to what? To a positive number. So it means you find the absolute value of it. I need to tell us why, because two lines are intersecting. If they ask you what's the angle between the two lines, you see that question is even ambiguous. When they say just find the angle between two lines, it's ambiguous because in this line now, this is an angle. It's the angle between the two lines. And it's the same thing as this one. They are the same thing. We also have another angle here. This is another angle.
Have 4 angles
there. Thank you. We have 4 angles there. Two opposite angles are what? Are equal. So this is also another angle which is what? Vertically opposite to this. So when they say, so if you look at this now, this one of them must be obtuse and one of them must be what? Acute, except if what? If they are perpendicular. If they are perpendicular, it means both the angles will be what? 90 degrees. Exactly. But if the two lines are not perpendicular to each other, so we must have an acute angle there, and we must also have what? An obtuse angle. So in this one, they want us to find the acute angle. So if it is acute angle that we want to find, even if you get negative answer here, the negative answer is just signifying that it is not acute. But if they say that you should find acute, it means the negativity, you are going to turn it to a positivity. So it's just like you are finding this one, you want to find this one, but they want you to find this. So that's just the difference. So it means even if you get the acute angle, you can use it to get what? Your obtuse angle. If you get this one to be 30, what is the remaining one will be what? It will be 180 minus 30. And that is just what? 150. If you get the acute to be what? To be 50, and you are looking for the obtuse, what do? You just remove 180, remove it from 180, and you get your what? Your 130. So acute or obtuse should not disturb you. Whichever one you are able to get directly, you can always remove it from 180 degree to get the other one. So that is it. Now, but because of the concept that we are looking at, so I told you that if you are thinking of angles in this kind of question, you should think of it in two ways. Majorly, we always apply this one in vectors. When you are given dots, when you are given vectors, you are given a vector A is what? 4i plus 5j. Vector B is what? 2i minus j. Find the angle between what? Between the two vectors. It's very easy for us. We adopt this particular formula. But this time around now, because of the fact that we don't know what our A will be, what our B is, we can't just equate it with X and Y. No. So to be able to approach this one, we are going to use the concept of, when we started, I said something, I mentioned something. I said the angle between two lines is the same thing as what? Remember, about 3 weeks ago when we started this particular, we said, and I explained that if you are looking for this, and our usual gradient is what? Dy dx, which is the same thing when you relate it to tan theta. Tan is what? Opposite over adjacent, which is changing y over changing x. Same thing as, so that's why we say tan theta is same thing as what? Gradient. Our gradient is same thing as what? Tan theta. So now, another concept that we have is what? The concept of what? Double angles. Double angles. We have what we call double angles under what? In our trigonometry. So we are going to use the concept of double angles in solving these particular questions. So what's the concept of double angle that we are trying to look at? I'm not going to stress us too much on this one. We have for sine, we have for cosine, because we are not concerned with that one now. So the one we are concerned about now is what? That of tan. So when you have what? Double angle for tan. Double angle, I mean, I can have maybe tan A plus B. What will it give us? So it will give us what? Tan A. Because what happened here? Okay, I will tell us why we need to use this particular concept. The major reason is just because we are looking for angle between two lines. So when you are looking for angle between two lines, for example, okay, I think I have to clean. Let me clean this. Please, if it is not clear, let me know. At any point you are not clear, so let me know so that I can always revert back and make necessary amendments. So what happened is that if you have this, the angle that we find, okay, the first one, if we want to find the angle that's what we did before, that we said the gradient is tan theta. Let's assume that the angle that this one makes is theta 1. That's from here to here. We use tan theta to get that. Now we want to find another angle. This is line 1. Let's assume that we have line 2. Line 2 is here. And line 2 makes another angle from here to this place. And we call that one theta 2. You know, the angle between them is this. It is obvious that if theta 1 is 45, for example, and theta 2 is what? 60. What's the angle between them? It is, you have to subtract. You can't add, because it's like from year to year is already 45. And they told you that from year to year is 60. What is from year to year? Simple logic. Just subtract 60 minus 45. It give us what? It give us 15 degree. So that is that. So it means indirectly what you have done is what? Theta 2 minus theta 1. So we need to find expression for theta 2 minus theta 1. So to be able to find the expression for theta 2 minus theta 1, we have to use the concept of tan A or tan A minus B. The one that we actually work for this one is what? A minus B, because we are not adding the angles together. We are subtracting. So the one we need is what? Tan A minus B, which is same thing as tan theta 2 minus theta 1. So what would that give us? I think I need to go to next slide to explain it better. So there is a concept in this area that they have already told us what tan A minus B will give us. So let's look at that concept. Okay. So to look at that concept, tan. So tan A minus B. Okay, let me use tan A minus B. That's where how you see it in textbook. It will give us what? Tan A minus tan B over 1 plus tan A tan B. If it is tan A plus B that you want to find, anywhere you see minus there, change it to plus. Anywhere you see plus, change it to minus. So if it is tan A plus B, for example, tan A plus B will be what? Tan A plus tan B over 1 minus tan A tan B. So now we are talking about theta 1 and theta 2. So as a result, it means tan theta 1 or theta 2 minus theta 1 will be equals to what? Tan theta 2 minus tan theta 1 over 1 plus tan theta 2 tan theta 1. But don't forget, when we started, we said m equals tan theta. So let m1 represent tan theta 1 and m2 represent what? Tan theta 2. So if you do that, it means you are going to have what? M2 minus M1, where M is talking about gradient, plus M2 M1. So if you are looking for look at tan. theta 2 minus theta 1 equals to what? Artan of what? M2 minus M1 over 1 plus M2 M1. So this is the formula that we are going to what? We are going to apply to solve question of such nature. So I hope it is clear. So let me just say, our time is fast now. I want us to actually finish this concept today. I don't want us to repeat the same concepts next week. So let me just use it to find one of the questions raised earlier. I think the question again. Find the acute angle between the lines 2y equals 3x minus 8 and 5y equals to x plus 7. I think what we just need to do here is that find M1 here. Sorry. Yeah. Find M1. So what is our M1? And then another thing, oh, yeah. I think we did not even consider that one much. Okay. Yeah, M1. How do we get the gradient? It's part of what we did not, what I just did not mention. So how do we get the gradient? When you have an equation. So don't forget that we said that the general equation or whatsoever, the general form, y equals to mx plus c. So the m there is the gradient. So if you are given any equation at all, that is how you can get the gradient. So look at the equation given here. They have given us equation 2y equals to what? 3x minus 8. So if you look at that equation that has been given, 2y minus. So for me to find you can't just say that what? The gradient is 3. No, you must make sure that the coefficient of y is what? Is 2. Is 1. There's nothing there. So divide through by 2 to make sure that you don't have anything as the you have 1 as coefficient of y. So if you divide through by 2, we have y equals what? 3 over 2 x minus 4. So what we are interested in is what? 3 over. So it means our M1 will be equal to what? 3 over 2. So we have got M1. The second equation that they gave us, they said 5y equals to what? X plus 7. 5y equals to what? X plus 7. So you also make what? Y the set of formula. Divide through by what? By 5. It means we have 5 equals what? X over 5 plus 7 over 5. So what we are interested in is what? Is that gradient. So which is what? 1 over 5 here. So our M2 is what? 1 over 5. So from here now, you can now apply the formula. So M2, 1 over 5 minus 3 over 2. So it means our answer will be what? The theta 2 minus theta 1, which is the actual, some people can call it phi. So that is just what we need. Phi, the angle that is called theta 2 minus theta 1. So we have 1 of 1 over 5 for that. Let me just tan of 1 over minus 4 3 over 2. 1 over 5 times 3 over 2 will give us 3 over 10. That's 10. Okay, so what will it give us? If you do this, that's 2 minus 15 over 10. 2 minus 15 over 10, that's minus 13 over 10. Minus 13 over 10. Let me see what I can use here. Minus 13 over 10. Let me just rub this. Minus 13 over 10. I have minus 13 over 10 there. So it means I'm looking for arctan of what? I have minus 13 over 10 as numerator. Denominator, what do I have? I have what? Also 13 over 10. Yeah, also 13 over 10, Abi. That's 1 plus TV over 10. 1 plus TV over 10 will give us what? 13 over 10. So you turn it upside down, it becomes 10 over 13 plus 10 over 13. So it will cancel 10, cancel 10, 13, cancel 13. Arctan of minus 1. So since it is acute that we are looking for, so you have to change that minus 1 to become what? Plus 1. So arctan of 1 will actually give us what? 45. So it means the acute angle is what? 45 degrees. If you press your calculator, arctan of 1. But if it is arctan of minus 1, you press, it will give you what? 135. And 135 is obtuse. But we are looking for what? Acute angle. So you just remove it from 180. You still get your 45. So that is how we solve such a question. We have just about 5 more minutes. Okay, so the last aspect that we'll quickly look at. I want to believe that you are following me. So the last aspect, I may not be able to dwell much on it. So we want to look at perpendicularity and then parallelism. So let me, since I can't hear anything from your side. Okay, I think I still have people here with me. It's just that you are not talking. Okay, so now from our derivation, from what we have derived in the last now, from what you have derived, what do you mean by perpendicular? When you say two lines are perpendicular, it means they form something of this nature. We have 90 degrees. That's perpendicularity. So it means the angle between them is what? 90 degrees. When they are parallel, it means they can't meet. So it means the angle between them is what? 0. Take note of that. The angle between two lines, if two lines are parallel, it means the angle between them is what? 0. So I'll say that there's no angle, but it's better we put it as 0. The angle between them is 0 because it's not forming any, we can't see any angle there. So it is better put as what? The angle between them is 0 degree. Now, so in such a case, if you go back to what we are able to derive, we are able to get that phi equals what? Arctan. Arctan of what? Of what? M2 minus M1 over 1 plus M1 M2 or M2 M1, whichever the case. So when our theta is 90 degrees, when our theta is, that is when they are perpendicular, or let's start from parallel. When they are parallel, it means that what? In that case, when they are parallel, so it means the angle between them is 0. It means the answer that we are supposed to get here when they are parallel, the answer is what? 0. So if 0 is equals to arctan of M2 minus M1 over 1 plus M2 M1. So it means that, this is arctan. If arctan should jump up and come to this side, it becomes tan. And tan 0 will give us 0. So as a result, you equate all this one to 0. And when you equate all this expression to 0, it means we are going to have M2 minus M1 is equals to what? It's equals to 0. So as a result, M1 will be equals to what? M2. So for two lines to be perpendicular, it means they must what? Have the same gradient. They must have the same gradient. So if you remember the question they asked us the other time for triangle, so it means the equation that you are looking for, they say which has the same, which is parallel to what? To line 2. It means it has the same gradient with what? Gradient of line 2. You just need to go and find the gradient of line 2. When you get the gradient of line 2, that will be the what? The gradient of the line that is passing through the what? Intersection of what? Intersection of L1 and L3. So that is what they are trying to say there. So so that this is the condition for them to be parallel. If they are now perpendicular, it means I'm going to have what? Tan 90 instead of tan 0. I'm going to equate it to tan 90. And what is tan 90? Tan 90 is what? Is infinity. If you remember, tan 90 is infinity. And we can say that well, it is undefined. So when this expression, if they ask you, when is this expression undefined? When we say undefined, an expression is undefined, it means that what? The denominator is equal to 0. Anytime we have denominator as 0 is a problem in mathematics. If you have 5 divided by 0 is a problem. It will give us infinity. So it means we have to what? Equate it, the denominator to 0. So if you equate the denominator to 0, we have 1 plus M2 M1 equals to 0. So that would be what? M2 M1 will be equals to what? Minus 1. So you can now say that what? M2 equals to what? Minus 1 M1. And at the same time, M1 2 is the same thing as what? Minus 2 M1. So if you look at this question, I say find the equation of the line which are parallel or perpendicular to the given lines through the point this. So for example, you first take, if you want to find the first one, because of time now, I don't think I want to solve any question on this. I will leave you to solve it. If there's any problem, you come back, you can revert to me, you can revert back to complain or so that I can take. So I don't want us to exceed the time. So in this case now, what do you just do? If you want to solve the first one, parallel. So it means you bring this line, you bring this equation out, you find the gradient of that line. And I've told you how you can get the gradient. Just make y the set of formula. If you make the y the set of formula here, we have y equals to x will come here to become minus x plus 3 or 3 minus x. But in this case, we prefer to write it as minus x plus 3. So the gradient will just be what? Minus 1, the coefficient of what? X. Minus 1. Since the coefficient of y2 is what? Is 1. So you don't need to divide by anything again now. So the gradient is minus 1. So if they are parallel, it means they are going to have the same gradient. So it's going to have the same gradient with the equation you want to find, the line you want to find the equation. So that is for parallel line. So it means the gradient, you are still going to use this point and your M1 there will be equals to what? Minus 1. For the perpendicularity, so the perpendicular line. So it means you have to come here and tell us if our M2 come here, if our M1 is equals to minus 1, what would be M2? So it means M2 equals to what? Minus 1 over minus 1. Exactly. So M2 will be equals to what? 1. So when you want to find the gradient of that one, the gradient, you still use the same point, but the gradient here will be equals to what? 1. So thank you very much for listening. I think I'm going to end it here. Is there any problem? Is there any question? Any question at all? So please, if there's any question, ask. I think I will help you to send this particular note. I'll send it to the class.
That, sir, please, is it on WhatsApp?
Yes, on WhatsApp. Any problem? Do you have any problem with the WhatsApp?
No, sir. No, sir.
Okay. So I hope you understand what I've explained. Any problem with